It's my great pleasure today to welcome our scientific development lead, Casper Crow, Dr. Casper Crow, to the webinar platform today to talk about rapid environmental contamination detection. Thank you very much, Casper. Over to you.
Thank you so much, Ben, and thank you for the invitation. So yes, I would like to talk a bit about rapid environmental control detection or sterility testing in a clean environment. And this assay really came about because we had a conversation with a big university in the United States, and they had a request for a assay to be able to detect contaminations in their gnotobiotics facilities. So in facilities where you have germ-free mice or other animals, that has to be 100% sterile for microbial contamination. And they had issues with their current system that it took too long to actually get results. The turnover time was slow. They were using external collaborators to get this testing done, and they used old-fashioned plating, and it could take up to over a week to actually get a result from their testing. And in that space, they were very afraid that they actually could get cross-contamination between cages. They were not sure if they actually got the results that they wanted. So they wanted to bring it in-house and also have a much faster turnaround, but also be sure that they really detected every single microbe they had, either in their incoming materials for feed and water and bedding, but also to test the environments. And some of the issues they brought up was really that they were afraid that they actually were missing out on very low microbial contaminations in their testing. And they brought up some of the issues that these compendium methods took so long that if you had contamination, this could spread and they could actually lose valuable experiments, but also that if you have these mice are insanely expensive, so getting isolated the contamination is very important, very fast. Then we have discussed quite a lot that there's a potential of, if you're going for more molecular techniques, that there's actually potential of getting a false positives, because if you have residue DNA in the environment, that can actually trigger a false positive, which also can be highly expensive in these environments. That if you actually have to put down a whole litter of mice or animals just because you have a false positive. Then we have also discussed the possibility of having biofilm contaminations in either the equipment they're using or water systems, and that sometimes these cells that are in biofilms can be viable but not culturable by these traditional techniques of plating or broth techniques. So based on this, we have developed a new assay and ran a whole project where we actually really want to address this and to develop an assay that utilizes SymCell's microcalorimetry system. And what we have built is an assay that actually can deliver results within hours instead of many, many days, even weeks. And this assay is able to really get an input of any sample that you have in these environments. It could either be solids or liquids, but it could also be swabs, swapping around the system to test if you have contaminations. And the neat thing is that this is a phenotypic detection system, so we'll only detect viable living cells of any microbe. So if you have residue DNA or anything else, that won't show up. It has to be viable cells. And then this is extremely sensitive. It is, we say, below 5 CFU, and that's just a statistical requirement that we can't really say, but in theory, it is down to 1 CFU that we can detect. The way that this assay works is it has a continued continuous monitoring of the samples, which also means that you'll get an alert right away when the system detects a viable viable microbes. So it's not an endpoint assay where you look at the plates after a certain amount of time. This is something that will give you an alert right away. And it is built on the biocalorimetry technology, which really is a assay that is based on using the metabolic heat and activity of living microbes to detect their presence. So anything that's alive will produce a bit of heat by just being alive through the metabolic activity, through anabolic process. Any biologic processes will produce a bit of heat. And if you have a presence of just one cell or more cells in your sample, when they proliferate, they will start producing heat, and we will detect that insanely precise down to microwatts. So we are able to see when they start proliferating if you actually have a contamination. But they have to be alive to actually produce this signal. And what actually comes out of this is the output that our machine is reading out on. This here is a Staph aureus in TSB, very simple. And what you'll see here, this is the whole growth and life of a Staph aureus culture. And you see that you have this nice signal and measured here in this heat flow of microwatts. But we actually don't need to have the detection of everything that's going on. The only thing we need to get is this small amount of heat as they proliferate. So we can actually just detect them when you see exponential heat output. And we can do that for more or less every microbes that we have tested. They will come up at different ways, but as we are only interested in detecting them reaching a certain threshold of exponential metabolism, we can detect this very, very fast. And we do this with this platform, the calScreener platform. And this platform is very versatile because we can throw any sample at it. I will come back to like the different things we've tried over the years. But it runs these 32 samples at a time, or less if you have, and you can either use a disposable glass vials that are normally single use, or you can use reusable titanium vials that has a bit bigger volume. And when you add your sample, then you throw into the machine, and then it will give you this continuous measurement and give you an alert if there's actually contaminations. And some of the workflow flow that we have worked with has been both with swabs, but also other materials that are in a gnotobiotic. We've utilized these environmental swabs from, I think we used Copan, but it could be any such system, and swapped very, very few amount of bacteria. And then we used this release buffer where you put in the swab that will release any microbes. And this also neutralizes any residue detergents or antimicrobials you might have in your environment. And then we basically just took this liquid, added into our samples, and then mixed it with TSB in a double concentration, which then give the microbes, will kickstart the metabolism inside of sample, then throw it into our machine, and then it's just incubating there until you get a detection or not get a detections. And it will give you this real-time alert. So it's very simple steps. And it's also really steps that limits the chance of contamination. If you're using these titanium vials, or these, they will be completely sealed. So if you're taking your samples inside of the clean environment, you can seal them and bring them outside and put them into the machine, or have the machine inside of the facility. But they will be 100% sealed. So this also really limits the danger of contaminating your samples doing your sampling. we have tried to challenge this system with different organisms that we know can be a bit of a tricky in these environments. And if we take 5 CVU and swap them up with these swabs and put them into this broth, and then throw it into the machine, we'll be able to detect Staph aureus around 9 hours. And all of these that we have tested are within the range of maybe 15 to 12 hours. So we can get quite very fast detection from 5 CVU. If you have more CVU, you'll get a detection much, much faster. But this has just been with swapping them up. And this is actually both from living organisms, but also from spores. And we know from a lot of our previous experiments that we can detect more or less everything within a few hours, both environmental organisms, yeast, fungi, bacteria from spores, not spore formers, and even cells that are very slow growing, like Gonobacterium acnes, that is super slow. We can detect that very fast in our assay. And as I said, this is when you're going down from like single digit CVU. But here, as an example, here we have an E. coli that's just been diluted 10 times. And as you move up in higher contamination, hopefully you don't have 10 to the 7th CVU in your facility, but you will detect that right away because it will just be faster and faster for the detection. And this is nearly on a linear scale that you're actually able to detect this. So as I said, that this is really, you're actually able to use this on any material. And the reasons why we know that is we have tested a lot of things over the years that might not be in a gnotobiotic or clean room facility, but we have worked with biofilms and soil and minced meat, cancer tumors, biopsies. We have used wound care products and even biocement. And because we are measuring heat, it doesn't really matter where in a sample you are. If you're a viable bacteria, it will be detected. So this also really enables us to work with stuff that are much more complex that you wouldn't be able to work with in traditional testing. So if we are taking it back to the gnotobiotic facilities, we can take fecal pellets and test for microbial contamination, water, CHO, bedding, or anything you will find in the cage. And actually, we normally have a saying, if it fits in the vial, we can test it. You can think about any of these that we can add that into the vial or chop them up, put it in the vial, and then adding nutrients, and in that way actually testing if there's any contamination, even if the bacteria are, or the microbes are inside of these. So, and we have a very large database over what we have tested over the years, and we know that we can find more or less any microbes that we have tested. We haven't hit anything that we couldn't actually detect yet because we just need a bit of heat from their metabolism. So just to wrap up a little bit, this system and this assay that we really try to tailor towards gnotobiotic facilities could be used in any clean environment. This has just been the request we had specifically for this, but you could think about it. It could be in other GMP environments, other manufacturing, but the advantage is really that we can get this turnaround time very fast, and you can have that in your facility. You don't need to send it out. So detection within hours, really. And it's very, very sensitive. We will, if there's viable bacteria or yeast or fungi, we will detect it. Then the bonus is that we are only testing these viable cells. You have to be alive. So that limits the false positives from residue DNA. And as I said, it is really the imagination that limits. Like, you can add any kind of material. If it fits in the vial, we can test it. and we can test more or less any microbe that could be a problem. And it is quite easy. It is very easy steps. So it is you don't need to be a highly trained scientist to work with this system. So we think that this is actually quite an ideal setup for having this continuous testing that is limiting any false positive and false negative in a setup for as a gnotobiotic or any other clean room. And we think that this could be really powerful. So I just want to put out there that we would love to hear and get inputs. We can tailor this in many ways. So it's very exciting for us to really get input from people who are working with this. So I'm gonna wrap it up there.
All right. Thank you very much, Casper. And yeah, anyone has any questions, then please feel free to reach out to Casper directly here or any of our sales team listed on the slide. So thank you very much.